Today we're going to be going over student handout number 1 from our unit on fraction operations. So please go ahead and take out student handout number 1 and fill in the blanks and follow along as we go through the lesson. So today we're going to be talking about factors and multiples. The first thing we're going to talk about and focus on the front are factors, and then on the back we're going to focus on multiples. So factors are the definition that we're going to talk about first. So a number, any number, could be 49, 83, 72. Any number is composed or made up of other numbers that we call factors. So in order to get 49, there are many ways that we could multiply to get 49. So 7 times 7 would be 49. And so factors of 49 would be 7 and 7. So let's look at an example down here. For example, 2 times 3 equals 6. So in this example, 2 and 3 are factors of the number 6. So these two numbers that we multiply together give us the product or answer of 6. So anytime we're multiplying two numbers together, the two numbers we multiply together to give us the answer are factors. When we have a set of numbers, so meaning two or more numbers that they give us, and they have the same factor, it is called a common factor. And we're going to go over some examples of common factors down below. The greatest common factor, which you might have heard of before, so the greatest common factor, also it's usually abbreviated GCF. So the greatest common factor is the largest factor that a set of numbers has in common. So we're going to look at two different ways that you could use to find the greatest common factor. And either one of these are fine methods to use. It just sort of depends on what your preference is and which one is easier for you to remember and understand. So it says there are several methods to help find the greatest common factor. So we're going to look at Venn diagrams and factor trees, and then we're also going to look at the ladder method. One or the other of them will be more comfortable for you, so you're just going to choose the one that you prefer. So it says determine the factors of the set 15 and 60 using a factor tree. Then organize the factors into the Venn diagram below. So in order to do a factor tree, you start by making little branches. And then you have to think of two factors that multiply together to give you the numbers that they give you in the set. So when I think of factors of 15, two numbers I multiply together to give me 15, I think of 5 and 3. There are not any factors other than 1 and 5 to give me the number 5 because it's a prime number, so I'm going to stop. And there aren't any factors that give me 3 except for 1 times 3, so I'm going to stop. These are called prime factorization. And that's what we're trying to do in the factor tree, is to get us to numbers that are prime numbers. So let's look at the number 60. There's lots of numbers I can multiply together to give me 60, but I'm going to choose 3 or 6 and 10. When I think of the factors of 6, I'm going to make another branch. And in order to get 6, I know I can multiply 3 times 2. In order to get a product of 10, I know I can multiply 5 times 2. So when I multiply those numbers together, I'm now down to my prime factorization. There's nothing else I can multiply except for 1 in itself to give me 3, 2, or 5. So now I've done my factor tree, and now I'm going to find the numbers they have in common. What I tell my students to help them organize themselves is to look for numbers that are in both sets, and I circle them. So if I see in 15, I see the number 5, and I also see the number 5 in my factorizing of 60. So I'm going to circle those two. And anytime I have a common factor, I like to write it down at the bottom. And what we're going to be doing to find the greatest common factor is multiplying all of these that they have in common together. So we're creating a multiplication problem down here on the bottom. Then I look at my other factor 3, and I see that 60 also has a factor of 3. So they have that in common. I'm going to circle it. And then I'm going to write this down here because we're going to multiply these together. So 5 times 3 is 15. They don't have any other common factors. This has two factors of 2 in our number 60, but because there's not a 2 over underneath 15, I cannot circle that one. So my greatest common factor of 15 and 60 is 15. In this example, they want us to do something where we organize the factors. This might be a little confusing, but I'll explain how they do it. So in the number 60 and 15, we're looking for the factors. In the outside circle, we're going to list the factors that each number has that they don't have in common. So when I look at 60, I see there's 2 and 2. 15 only has the factors 3 and 5, but they both have that. So I'm going to write those factors in the middle, and that's what we multiply to give us our greatest common factor of 15. You don't need to draw the Venn diagram. It's just a way to organize and visualize your thoughts. So this is one method, using the factor tree. The other method is what we like to call the ladder method. And in order to use the ladder method, you divide out common factors and then determine the greatest common factor, or the GCF. So let me show you what that means. When I look at this set of numbers, 20 and 16, I know that a common factor that they both have is that I can divide them both by 4. So I'm going to write a 4 over here on the left, and then I'm going to make another ladder, and I'm going to divide both of these numbers by that. So 20 divided by 4 is 5, and 16 divided by 4 is 4. So now I'm going to look at these two numbers, 4 and 5, to see if they have any factors in common. Well, they don't. So that means these are prime factors, and then I look here at the side, and what I do is I multiply the numbers together that I see here on the side. So I only see 4. So that just means that my greatest common factor is going to be 4, because 4 times 1 is 4. Let's look at another example. So I have 24 and 40. So I see both of these are even numbers, so I'm going to start by dividing them both by 2. So if I take and divide 24 by 2, I get 12, and if I divide 40 by 2, I get 20. These still have some common factors. So when I look at 12 and 20, a common factor that I know they both have is 2. So I'm going to create a new step on my ladder, and I'm going to divide them now both by 2. So 12 divided by 2 is 6. 20 divided by 2 is 10. I'm going to look at these two numbers and see if they have a common factor. They're both even, so I know that they have a factor of 2. So I'm going to create another little step. 6 divided by 2 is 3, and 10 divided by 2 is 5. I know that these do not have any common factors and that they're both prime, so now I can stop. What I do now is I multiply each one of these together to get my greatest common factor. So I'm going to multiply 2 times 2, and that gives me 4. And then I'm going to multiply 4 times 2, which gives me 8. So now I want you to choose whichever method you're more comfortable with, and I want you to try number 1 with that method. You can either do the factor tree or the ladder method. Either way, you should get the same greatest common factor. So in example 1, you're going to create a factor tree or the ladder method to find the greatest common factors of 24 and 6. So pause the video, go ahead and do your work, and then come back and check your work with mine. So let's go ahead and look and see how you did. So if you used the factor tree, you would have written down factors of 24. You may have written 4 times 6. You may have also written 8 times 3. No matter which numbers you've written, we should get the same answer in the end. So the factors of 4 are 2 times 2, and the factors of 6 are 3 times 2. Now these are all prime numbers, so I know I can stop. Now I'm going to do the prime factorization of 6, and I know I multiply 3 times 2 in order to get 6. These are both prime numbers, so I can stop. Now I look at both of the prime factors, the branches, and I'm going to circle what they have in common. So I see a 3 under 6 and a 3 under 24. I'm going to circle both of those, and I'm going to write them down. because this is going to be how I find my greatest common factor. Now underneath 6, I see 2, and under 24, I see 2. So I'm going to circle those and write them down on the bottom. Now I have these 2 over here, but because they're both under the same number, they don't count. I can't circle those. They don't both have this in common. Now I'm going to multiply 3 times 2 and I get 6. So that means my greatest common factor of 24 and 6 is 6. Now we're going to look at number 2. I'm going to walk you through this one because this time they give us 3 numbers instead of 2. You can use the ladder method or the factor tree for this, and both will work. So I'm going to use the factor tree. I'm going to prime factor each number, and I'm going to find the numbers they have in common to find my greatest common factor. So 18 can be found by multiplying 9 times 2. 2 is a prime number, but 9 is not. So I know I get 9 by multiplying 3 times 3. I know that 3 is a prime number, so I know I can stop. 24 can be found by multiplying 8 times 3. 3 is a prime number, so I can stop, but 8 is not. I know I get 8 by multiplying 4 times 2. 2 is a prime number, 4 is not. I'm going to multiply 2 times 2 to get 4. And now I have my prime factorization. Now I'm going to go and do my final number, 60. And I find 60 one way by multiplying 6 times 10. Now I need to factor each number. So 6 is found by multiplying 2 times 3. Those are prime numbers. And 10 is found by multiplying 5 times 2. These are also prime numbers. So now, just like I did for the examples that showed 2 numbers in the set, now I have to find factors that are common amongst all 3 numbers. So I see a 3 in the 18, a 3 in the 24, and a 3 in the 60. I'm going to circle those because that's one number they have in common, and I'm going to write it up to start my multiplication sentence. 18 has a factor of 3, but 24 and 60 do not, so I can't circle that. But if I look at 18, I see a factor of 2, a factor of 2 in 24, and a factor of 2 in 60. So I know that I can circle those. So now I'm going to multiply because there's nothing left that all 3 of them have in common. These are my common factors. I'm going to multiply them together. When I multiply 3 times 2, I get 6. So therefore, my greatest common factor is 6. So stop this video and go ahead and turn to the back, and we will start on multiples.